Hello, everybody. Welcome to our closing industry webinar on PASS START-PROF, a comprehensive solution for pipe stress analysis. We are beginning our session, and today we will talk about PASS START-PROF capabilities specifically for district heating industry. During the webinar, you will learn how PASS START-PROF can help you significantly increase your productivity, save your time, and increase the accuracy while creation of a district heating system model, its analysis, and reports generation. We will also cover new features of PASS START-PROF that will be available in the new version to be released next week. Now, I would like to invite Dr. Alex Matveyev, the head of Pipe Stress Analysis Department, to start the presentation.
So let me introduce myself. My name is Alex Matveyev, and I'm the head of START-PROF pipe stress analysis software development team since 2005. Also, I perform trainings on pipe stress analysis software and technical support. You can contact me via the links that you can see here. This is the quick introduction into this webinar. The first part is quick introduction to PASS START-PROF software. The second part is the features of district heating pipelines, district heating networks analysis using PASS START-PROF software. And the third part is the features and usability of PASS START-PROF software. Let me quickly introduce what is the START-PROF. START-PROF is the industry standard in several countries like Russia, Kazakhstan, Belarus, and Ukraine. And it is widely used for the process piping, process industry, for power industry, in the gas and oil pipelines, and of course, district heating networks, design and analysis. PASS START-PROF is very user-friendly software, so it can increase the speed of your design and reduce the cost. START-PROF software developed since 1965. We have about 2,000 active users, the companies. The user interface and documentation is on English, Chinese, and Russian. We have 32 piping codes, and we have 18 codes for wind, seismic, snow, and ice loads, automatic generation. This is the main users, the most famous users from these different industries, the most famous international users, and almost all Russian companies who design the district heating networks and who produce the pre-insulated pipes with polyurethane insulation, the manufacturers, including the most known and the most famous Mosflow line company, use PASS START-PROF software. What is the benefits of PASS START-PROF? This is the direct support from developers via email. The software is very easy to learn, very easy to use, and it has very intuitive, modern, object-oriented user interface. And PASS START-PROF is the part of the PASS suite that consists of several software. It's pipe stress analysis software, hydraulic and thermal analysis that is also used for district heating network analysis, nozzle FEM, and equip for different type of equipment analysis. So PASS START-PROF is very easy to use, as I said, and it allows you to achieve the result quicker. and you will spend less time for model creation, analysis of this model. The codes that is widely used for distributed network analysis and what is included into PASS START-PROF software, you can see here in this list. Many years we had the Ghost code for distributed networks. Several years we have Chinese codes, and also in this new version we added the European code for the distributed network analysis. So let me tell you quickly tell you the history of distributed design in Russia. Since 1965, the handbook, Nikolaev's handbook, was very popular for design of the distributed networks, and it was divide the pipelines into several sections, like L-shaped loop, the U-shaped loop, and the Z-shaped loop. So the distributed networks was look like this, as you can see on this picture. Since 1998, the directly buried underground pre-insulated pipelines with polyurethane foam insulation began to be widely used in Russia. And also the Peter Randloff handbook became very popular worldwide since 1997. But the complex design of distributed systems can be analyzed using that simple method with division of all the piping system into simple components like U, L, and Z shape loops. And START-PROF software became more and more popular for design and analysis of such systems. And also the directly buried pipelines, distributed pipelines, was impossible to analyze using that handbook, the Nikolaev handbook. And most companies change their design and used the PASS START-PROF software. For example, the main problems usually happening with the T's, and also some accidents was happening. You can see here how does the T works. This is the underground chamber with the intersection of two distributed pipelines. This is the stress level, and you can see that T element is we have the problem with the T element because the stresses in the T element are great. And the simple manual methods can't allow you to check the stress in the T's, bands, and other elements. And you can't check the fatigue analysis of distributed network. So some accidents was happening time to time with distributed networks, and many companies turn to use the more accurate computer analysis design and change the design to using the START-PROF software. Here is the example of the buried distributed network. In PASS START-PROF software, you can see that the soil is modeled using the special soil springs. The underground, here is the underground chamber with intersection of the pipelines, the valves. So there are a lot of distributed projects in Russia. The diameters is from about 200 millimeters to 1.4 meters. And almost all distributed networks now are designed using the best START-PROF software in Russia, Kazakhstan, Ukraine, and Belarus. And also, since 2015, the China joined the Society of START-PROF users. And now a lot of district heating projects in China performed using past START-PROF software. Here is the one of them. It is the long district heating network with the diameter 1.2 meters, temperature 150 degrees Celsius, and the pressure 1.6 MPa. This is a very long pipeline because the power stations in China are all, usually placed out of the city. It is not inside the city. It is not allowed, and it is placed outside the city. So the district heating pipelines are very long. And also, this is another example. This is the buried hot water piping network project that was done using best START-PROF software for the Beijing Universal Amusement Park. Here is that network. It is a very huge network. Also, we perform a lot of trainings over our software. This is some of them. We had about 100 attenders for each training. So now past START-PROF is widely used in more than 800 companies in China, Russia, Ukraine, Belarus, and Kazakhstan for district heating network analysis. START-PROF has all the needed capabilities to design and analysis of the buried district heating networks. We had special algorithms, nonlinear analysis of gaps, friction, one-day restraints, soil springs, everything that is needed to perform pipe stress analysis of district heating networks. We have a special generator of the external loads from the snow, wind, ice, seismic. And due to 18 national codes, also with integration with hydro system software, we can calculate the hydraulic effect like water hammer. So let's talk about the buried model, the model that is used for buried pipeline analysis in past START-PROF software. The continuous soil resistance is replaced by the discrete springs that is placed along the pipeline. To save the machine time, the computer analysis time, and the memory, we use the special algorithm that divide all the piping system into 3 zones. The first zone is lateral bearing zone. There the bending moments are great. The length of the zone is calculated automatically by past START-PROF. So we place a lot of springs at that zone. So the springs are condensed in that zone. The second zone with less condensation of the soil springs, this is the sliding zone. In that zone, past START-PROF place less springs, and the third zone is restraint zone. But actually in district heating networks, the restraint zone are not happening, because in restraint zone, due to high temperature of the district heating networks, the stresses are usually greater than allowable. So the restraint zones usually are not happening. It can happen only just if the temperature is not so high, and special methods like a single-use compensator or preheating analysis method was used. So in the restraint zone, the pipe doesn't move. The thermal expansion is zero because it is balanced by the friction forces in the sliding zone, and the pipe behavior like the pipe that is restrained between two anchors. In such type of zone, START-PROF place the soil springs with a distance of 100 diameters. Also, we have the long radius pipe bands, and for example, in Russia, it is not used for district heating networks, but in China, it is very popular because district heating networks are very long and lying near the roads, and they use the long radius bands very widely. We have two types of long radius bands. It is the ordinary long radius band that can hold its shape. If you place this band on the ground surface, it will still remain the band. But we have also the pre-stressed long radius band. If you will cut this band from the pipeline and put it on the surface, it will tend to return to its original straight form. So it has the initial bending moments inside the band that try to open it, like you can see on this picture. And also it adds additional stresses in such bands. The soil model, how does the soil spring works? We have three soil springs. It's a longitudinal soil spring, it's vertical and horizontal soil spring. The horizontal soil spring consists of three springs. First one, model the polyurethane foam insulation flexibility. The second spring, model the expansion cushion or expansion pad flexibility. In START-PROF, you can just select, do you have the cushion on this pipe or not? And START-PROF will add this spring if needed. And the third spring, model the horizontal soil resistance. The same situation is for vertical spring. And axial spring doesn't have the polyurethane foam flexibilities. It is just the soil flexibility along the piping, along the pipeline. START-PROF automatically calculate the polyurethane foam insulation flexibility and automatically calculate the expansion cushion flexibility. So you don't have to care about it. You just need to select which type of insulation you're using, and you need to select do you have the expansion cushion on this part of pipe or not. And about the soil model. This is the axial soil spring property that is used for modeling of the soil spring. And also we have another model for district heating networks. Also START-PROF allows you to choose which type of lane you're using. Is it open trench or trenchless? And if you're using the trenchless method, like horizontal directional drilling, START-PROF will also consider the special natural edge collapse phenomena about the pipeline. This is the properties of the horizontal spring, soil spring. This is the properties of the vertical soil spring. It is trilinear soil spring, and at this point, the distance is the depth of the pipe axis to the surface, to the soil surface. This is the L value, and this is the L value too. So then pipe goes up and get out of the soil. The soil resistance became 0. START-PROF can analyze the pipes with different soil depth on the two ends of the pipe. So you can specify the depth on one end and the second end, and START-PROF will model it automatically. It will calculate the properties of each soil spring automatically depending on the depth for individual depth for each soil spring, including the vertical pipes. Also, START-PROF model allows to model the pipe with any angle from the horizontal to vertical. It automatically converts the soil properties to model the inclined pipes, vertical pipes. So most of the soil models are usually designed only for horizontal pipes, and some of them doesn't have the properties for vertical springs. So START-PROF include the soil model that has this ability. In one model, you can analyze both the above ground and underground pipelines in the same model. And also it can consist of inclined pipes, vertical pipes, no problem. So you just need to draw your piping system, your district heating network with above ground pipes, with underground pipes, and START-PROF will automatically analyze it. START-PROF has the soil database that contain the soil properties, and also it has the sand properties that is usually used in the district heating networks. And also START-PROF can check the stresses. Here you can see the stress table according to EN code 13941, this European code. And here you can see the force controlled action membrane stresses, the calculate stress and allowable stress. The membrane and bending stresses, force controlled here. The stepwise plastic deformation, it's forces and deformation controlled stresses here. And it can calculate the low cycle fatigue. This is the expansion stresses. So all type of stresses automatically checked in past START-PROF software. Load cases are created automatically for district heating networks. So you just need to draw your piping model and run the analysis. And also START-PROF check the buckling effect according to European code, and offer you the buckling check report for all the pipes in your system. START-PROF has the ability to enter the number of cycles for different type of pipelines. It's transmission, distribution, and house connections. You can enter the number of cycles, and for each pipe you can specify the type of pipeline. Is it transmission, distribution, or house? So you can analyze the whole district heating networks that can include all type of pipelines, houses, distribution networks, and transmission networks. So you can analyze everything in one model. And also START-PROF has the database with polyurethane insulation pre-insulated pipes according to the standards and for the manufacturer catalogs of different manufacturers. It is the GOST Russian catalog and Chinese national standard and the popular LOGSTOR, POWERPIPE, and other standards. START-PROF can analyze the ring bending stresses in the pipeline. To do this, START-PROF calculate the loads from the soil pressure over the pipe perimeter, and START-PROF create the special finite element model of the pipe cross-section with the loads applied around this cross-section. This cross-section also include the polyurethane foam layer insulation around the pipe, and it automatically consider the pressure stiffening effect. So this finite element model is nonlinear. When the internal pressure is very high, it tends to open the pipe tend to become a circle cross section, and if the pressure is zero, it overlies, so it became elliptical. This effect automatically considered too. Here you can see the bending moments diagram in the pipe cross section, and this is iteration process. How does the iterations done inside the START-PROF? And you can see here that some springs are switched off. The soil is modeled using the special springs around the soil springs around the pipe cross section, but that springs should work only for compression. The compression happening in this zone. This is compression zone, and this is tension zone. In this zone, the soil springs are automatically switched off. So this model is very accurate for bending stress calculation. And this stress is used in the European code for district heating networks and automatically considered during the stress calculation. Also, START-PROF can analyze the stresses in polyurethane foam insulation. Here you can see the stresses in insulation. This is very important because the friction forces that is acting on the insulation must be passed from the insulation to the steel pipe inside the insulation. That forces are very high, and the insulation must be glued to the steel pipe very strongly. The adhesion should be very strong because it needs to hold the great forces, and also the water should not come in between the insulation and the steel pipe. So START-PROF check the stresses according to the EN 253 code automatically and use some results from the cross-section nonlinear finite element model calculation and also from the beam element pipeline model calculation, combine it and calculate the equivalent stresses and tangent stresses in hoop direction and in axial direction of the pipe. So START-PROF check the insulation stress. Also, START-PROF can analyze the insulation and pipe and insulation under the external loads on the ground surface. For example, from the heavy trucks above the pipe. Also, START-PROF can take into account the preheating and the single-use compensator. We have a special option where you can just select which type of do you have the preheating or single-use compensator, so it's very easy to use. And also START-PROF can calculate the distance between the single-use compensators. So let me demonstrate it in the START-PROF software. I just open the START-PROF. Here are some examples. Here, this is the examples of district heating networks in START-PROF. Let me show you the single-use compensator model. This is a very simple model, very simple model. I choose the European code for the district heating I choose the single-use compensator. This temperature, we lock this expansion joint, we weld it, and it is not working anymore after we locking it. So let's perform the analysis of this system. You can see the soil springs along the pipeline, and you can see the stress table. The stresses, according to the European code, is okay, no problem. You can move your mouse over any cell like this, and you will see all the equations that is used according to the European code to calculate the stresses. And expansion stresses. So you can check all the calculations manually if you want. If you have any problems here, START-PROF will draw this cell using red color. Check report. Here is the buckling check. Everything is okay here too. No problems. And this is the expansion joint deformations. You can see the axial deformation and allowable deformation of this single-use compensator. So let's remove the single-use compensator here. I will remove it from this model and run analysis again without single-use compensator. Now you can see that we have the problems with the stresses. Let's check buckling. We have problem with buckling, so single-use compensator help us a lot. And also, I undo changes, return back the single-use compensator, and let me change the lock-in temperature. I can change it from 65 degrees to, for example, 20 degrees. Run the analysis. And you can see that we also have some problems with stresses. So the lock-in temperature should be the temperature between the installation temperature and operation temperature divided by 2, like this. This temperature is the lock-in temperature of the single-use compensators. Another example of a preheating analysis. This is the model, sample model that can demonstrate how to perform the preheating analysis. Here is the preheating method was chosen. And in operation mode editor, we have 2 operation modes. The first mode is without preheating, and the second mode is with preheating. There is no preheating, and here is preheating. And we can compare 2 models and compare the results. So the analysis is already done, so I will just show you the results. This is the stresses. Oh, they was cleaned, so I need to run analysis. Okay, analysis is done. This is the deformed shape of this pipeline. This is the first one. This is normal way without preheating. You can see this is installation state, and this is operation state and cold state. So this is installation state, operation, and cold state. And if I will change the model to preheating, you can see another results. This is the installation state, operation state, and cold state. As you can see, the difference. This is preheating, and this is without preheating. The difference is significant. So all the model is calculated with preheating. Now, let's check results. Here is the normal way. We have problem with stresses. And also we have problem with buckling stresses. But if we change to preheating, all the problems are gone. No problems now. And let's check stress, normal way. We have problem, and preheating, no problem. So preheating helped to reduce the stresses and support loads in the piping system. It is very easy to activate it in START-PROF. And another samples, let me show you. This is the Universal Studios in Beijing, heating network, Beijing, China, for Universal Studios Park. It is very huge heating network. So let's, okay, here is it. Okay, this is the heating network. Very huge. You can see the expansion joints here, expansion loops here, the valves. Very huge heating network, and this is not the final results in the final system. The connections like this was used everywhere, but this is just intermediate results. Connections like this is not working for district heating networks. So this is not final version of this network. We turn to that type of connections at every point. And also, let's check the deformed shape of this network. Okay, I remove the installation state line, and we can run analysis. This is the deformed shape of that district heating network. And also you can check the insulation stresses. They are not passing right now here because, as I said, this is not final version of this model. In the final model, everything is okay, but here we have the problem with equivalent stresses in insulation. And we have a lot of other examples. Let me show you just one, another one example. This is the district heating network pump station in China. That was analyzed using START-PROF software. And let me show you the soil surface above the underground part. And this is above ground part. This is the pump station. There is a lot of pumps here. And let me show you the diameter of this pipe. You can see the diameter is 1.4 meters. It's a very huge diameter pipe. And it was analyzed using START-PROF. And the cross sections, this is done automatically in START-PROF. And now I will show you the deformed shape of this hidden system. This is the pump station, and this is the underground network. This is not final model 2. In the real model, we have a very, I don't have the final model of this piping system. Okay, so let's return to our slideshow. Here is the diagram of the stresses or axial forces in the pipeline. Then we're using the single-use compensators, and the diagram when we use the preheating. Also, START-PROF automatically use the full friction for hot load and half friction for cooling. So we automatically analyze it, and with this adds us the additional safety margin because the expansion stress range became greater. And START-PROF automatically calculate the cold state. For example, we have installation state, operation state when pipe heating up. And when the pipe is cooling down, it is never returned to original installation state because the friction forces change their direction. And in cold state, we will still have the very huge friction forces, especially for buried piping systems, for underground piping. This is very important to calculate the accurate stress range. So START-PROF done this automatically, and this is especially important for district heating networks. This is the expansion range between installation state and operation state, this one. And this one is the expansion stress range between cold state and operation state, and it is the greatest. So we need to consider the friction forces in the cold state of the piping system. We have the database with insulation diameters of the most famous manufacturers of district heating pipelines. Like the Russian GOST code, because all the manufacturers in Russia follow the GOST code. The second one is China's national standard. And the next one is LOGSTOR, POWERPIPE, and others. We have the database, the material database that is including all the European materials in our database, including the materials that is used for district heating network design. This database it contain the properties of the material depending on the wall thickness that is required by the European standards. So START-PROF will automatically select the appropriate material properties depending on the wall thickness. You don't have to do this manually. Just select the material and select the manufacturing methods. It's seamless or welded. And START-PROF will automatically consider everything else. Also, START-PROF can analyze some special effects like soil subsidence, landslides, seismic fault crossing. This was very important for China because there are a lot of seismic zones and district heating networks cross that zones. So START-PROF allows to do that. You can define the soil movements at the beginning of the pipe and at the end of the pipe in any direction, and use it to model the effect that you can see here. Also, START-PROF in the latest version, START-PROF can analyze the seismic wave propagation effect according to several standards, including the Chinese standards, United States standards, and Russian standards. You just need to select the seismic analysis and select the buried pipeline seismic analysis. So START-PROF can now perform the seismic analysis for buried pipelines, for underground pipelines. You just need to select the standard. What is the wave propagation effect? When they have a long pipeline, the P wave, it's a longitudinal seismic wave, pass through the soil, and it causes the forces in the pipeline. It has the compression zones and tension zones. The friction forces between the pipeline and the soil reduce this effect, so it make it much better. And START-PROF use these equations to calculate the strength in the pipeline during the seismic wave propagation. Especially the most important points, it's the branches of the pipeline, because the branches can't slide along the pipeline, along the soil. There is the friction forces can't help it, and it moves along with the soil during the passage of the seismic wave along the pipeline. So the most of problems are happen in the branches. START-PROF allows you to design the branch which will hold the seismic wave. This is the method that is used for seismic wave analysis. You can specify the peak velocity value, peak ground acceleration, apparent propagation velocity of P wave, and for S wave. How to define that values you can find in our help system. You can just open our help system and find the answers for your questions in that help system. Another one, after the analysis, START-PROF allows you to automatically check the strains in your pipeline. In the pipeline according to several standards. So if you choose the ASCE code, START-PROF will check using ASCE code. If you check Chinese or Russian code, START-PROF will use that codes for checking of the seismic wave propagation effect. Okay, so now let's talk about START-PROF usability. The START-PROF software is object-oriented software, and you can build your piping model from the objects like Lego. The objects can be the pipes. For pipe objects, you can define different coordinate systems. It can be projections, or it can be cylindrical coordinate system that is more convenient for using in district heating networks. And also you can select any type of object, for example, bent object, and put it in the START-PROF model. We have T objects, reducer objects, valve objects, pump objects, expansion joint objects, The special type of expansion joints, it is the torsion expansion joint with the friction moment and the slip joint with the friction force that is widely used in district heating networks. They have flange object that automatically check the flange leakage. START-PROF can consider the insulation weight automatically if you input the insulation thickness and density, or you can choose the insulation from the database. For example, this database contains insulation weight for the district heating pre-insulated pipe manufacturers. We have all the needed types of the supports in START-PROF. Also, we have a non-standard support that consists of 6 supports: free rotational and free linear restraints, and you can create your own support and then copy it. It will be the one object that will contain several restraints inside that object. You can easily define the displacement of the supports. You don't need to use any special tricks. You just add the displacement for a support and START-PROF will take it into account. You can define the cold spring. The cold spring is widely used for district heating networks too, especially for above ground district heating networks. So you can easily add the cold spring. START-PROF allows you to calculate the wall thickness of the pipe, wall thickness of the band element, and for reducer according to the district heating codes. You can analyze the distance between supports, the stability analysis, the buckling analysis. You can check the stress insulation for buried pipelines. And also we have the special feature, especially for district heating networks. Some companies like the manual methods, like Nikolaev's handbook, like LOGSTOR guidelines, like other handbook guidelines. They have the special equations how to calculate the U-shaped loop, Z-shaped piping loop, and the L-shaped piping loop. So START-PROF allows you to do the same job, but using the finite element method. You just select the type of your piping loop, specify all needed values, and START-PROF will calculate it. Sometimes some companies use this for quick estimation of the heating network, but after using this quick estimation, they perform the real analysis using the main core of START-PROF for pipe stress analysis. Here are the reports that you will receive after the analysis. It's a pipe stress, insulation stress, seismic stress, flow stress, restraint loads, nozzle and equipment loads, displacements, expansion joint deformations. START-PROF will automatically check the expansion joint deformations, the buckling check, and flange leakage check. The reports can be copied to Microsoft Excel, to Word. Also, we have the free viewer. If you will design your network, you can send it to the customer, and customer can download the free viewer, open your network, and check the design in 3D and check the results. This is how interactive reports looks like. This is the loads report, displacement. You can easily check the axis from global axis to pipe support axis, or pipe local axis. Here are the stresses. You can move your mouse button. I already shown that to you, and you will see all the equations what was used to calculate stresses. They have the special error and warning messages, and your goal is to remove all the red messages from this window. This means that you don't have any problems anymore. If you see the red messages, this means that you have some problems in your system. The messages happening before analysis or after analysis. This is a feature that many of expert companies who approve the district heating network design in Russia, they like this window very much because they just ask the design companies to offer the START-PROF project file to them, and then they run this file using the latest version of START-PROF, and if they don't see any problems here, they are satisfied. Also, they check the design of the heating network in START-PROF, and they check the accuracy of input data in START-PROF, how accurate it was, the piping system was modeled, and if everything is okay, they approve the design project of district heating network. The software is very reliable. We automatically verify each version of our software on more than 300 examples and compare it with the previous version of the software to avoid any bugs in the software. Also, we have a special focus group of pipe stress expert who test each release of START-PROF, and also after each release, before each release, they perform past START-PROF trainings, and each release pass through about 1 to 3 pipe stress trainings with the group of students, from 10 to 20 students who learn our software, how to use it, and if we will find any bugs, we'll just fix it before official release. And also, after the official release, as we have a lot of users of our software, so if they will find any bug, they immediately report us and we fix it very quickly and offer the next release. So the pipe stress software is very reliable. Okay, Marina.
Thank you, Alex. Thank you for your meaningful presentation and impressive examples. And I would like to say that we will start the Q&A session shortly. And before we do that, I would like to let our participants know what other resources we have about START-PROF and other solutions included in the PAS suite. We have a website where you can see the information about our software and download a free trial version. We have a YouTube channel with the list of many useful videos. Yes, this one. Can you back to the previous slide, please? Yes, we have official groups in social media, so you can see the links to our groups there. And besides, we have a lot of articles, and most of them have been written by Alex. So you can see the link where you can read the information, the detailed information about START-PROF. And also, we have many more resources, and we continue to add some new content. So please follow up us in social media. Thank you, Alex. Thank you, dear participants, for joining us today. I hope you also enjoyed the webinar. If you have any other questions, please send them to the specified email addresses that you see on the screen. And I would like to wish you all a good rest of the day and hope to see you during our next webinars.